An electric current is a flow of electric charge. It's telling us how much charge is flowing past each second. In physics, we always consider the movement of positive charges to give us the direction of current flow. And we call that conventional current. I'll explain a little bit more about that at the end, because I can hear a few of you going, hang on a minute, what about electrons? We'll take a look at that in a moment. Current can be measured by connecting an ammeter in series with a circuit. Now, here's a typical circuit involving a power source, a battery, source of current, and a resistor, which is going to take the battery's electrical energy and convert it into heat. We need to copy and complete the circuit diagram to show how we can measure current in series with this circuit. So let's take a look at that now. So first of all, let's set up the battery, which is two cells or two or more cells together. The dotted line means there are perhaps more cells within there. Okay, and now the positive terminal is the larger side. So that's the positive terminal. And positive charge, we say, is flowing from that terminal. So we're going to give that the letter I, which is the physics symbol for current. I think they ran out of letters. Okay. So that's going to flow around the circuit. Now, in order to measure the current, the flow, think of it like water flowing through a pipe. We're going to need to put a flow meter in here. And that flow meter is called an ammeter. An ammeter. And it will measure the flow of current going through it. And it's connected in series. And when something is connected in series, it means that it's in the same loop. It's in the same loop. So we carry on now, and this charge will continue to flow through the resistor, R, and then it makes its return journey back to the battery, back to the negative terminal. Okay, so that's an ammeter connected in series. In the same loop, there are no junctions. Otherwise, that would be a parallel circuit. Now, for those of you who are wondering about this definition of current, that it's a flow of positive electric charge, and asking, well, hang on, what happens in a metal? Surely the charge carriers in a metal are electrons. Yes, they are. It's true. Electrons are negative, and it's the flow of electrons which creates an electrical current in an electrical circuit. So we say, yes, the electrons are flowing from left to right here, but the conventional positive current is flowing the other way. That's the flow of positive charge. That might be a bit confusing, but let's see if I can explain that. I'm going to draw some electrons, and they're going to be moving to the right. I'm going to leave a little gap here. So let's move this electron one space to the right. So now what we've got is the first two electrons in the same place, but now the new electron has moved to here. So our negative charge has moved to the right. That's our negative charge movement, because each of these electrons is negatively charged. But we could think of positive charge as the hole. And here is the hole that has now moved to the left. And that's how we think of positive charge in a circuit. Now, I'm going into more detail than you need here, but I just wanted to explain that that's the reason that we use conventional current. Conventional current, and that's the flow of positive charge, goes the other way than the electrons. All you need to remember is that current is a flow of electric charge, and it can be measured by connecting an ammeter in series with a circuit. And that means the ammeter will go in the loop of the circuit, just there.